This is a do-it-yourself movie on how you can make a turbocharged fuel-injected Trike. What I did in 1989, I bought a Volkswagen, 1975 Volkswagen that was shot. It was so rusty that when we pulled it up to where I was going to work on it, I pulled the car in two. But the part that you need is the big chunk out of the back with all of the stuff on it, the shifter, the tranny, the wheels. And it was a great package. In the 80s, everybody was doing Volkswagen parts and using Volkswagen chassis stuff to do it. And I was too. So I went through the engine, which took not very much time at all, and that was back in '89. So this engine has not been apart since 1989, long time ago. And it's worked really well. At first it was carbureted. And the carburetor didn't work very good because carburation has all of its faults, dead spots, don't run right cold, all of the troubles that Volkswagen had when they carbureted something. So I switched to fuel injection. Actually took the fuel injection off of an old Volkswagen, which this was, and put it on this one, and it ran really good, you know, in spite of how crude the fuel injection was. Then I decided I would turbocharge it, so I got a turbocharger off of a 1984 Pulsar NX and put that on it. Then I decided that the fuel injection could be upgraded if I would use something a little more modern, but not too modern, because too modern locks things out that I want to change. And so I went to a 1991 Saturn twin cam, which was a multi-port fuel injection, and this Trike is now turbocharged with a Nissan Pulsar Air Research turbocharger and a Bosch influenced 1991 Saturn twin cam fuel injection, and how I married it together. Because when you put all of this stuff on, everything's got to play nice in the sandbox. And I had experience with a lot of automotive stuff because I've been a mechanic since 1965. And when I quit, I was an advanced level certified master mechanic. 4 years after I got done with that, I went up and taught lab at South Central Technical College in Mankato. So this is how I did it. And there's reasons why I went to fuel injection. And I wrote down everything that I could think of this morning as a reason. The advantages of fuel injection: it starts immediately. There's no pumping the gas, no accelerator pumps, none of that stuff that makes you wonder if it's going to start. It can learn and adapt by itself to the engine that it's on. So I bought a 1900cc fuel injection to put on a 1600cc bike because I need more fuel when the boost is on. Also, I can change the inputs. In other words, you could say that you lie to what's going into the computer to get the result that you want. And being it can learn when you're just cruising down the road, the thing takes care of itself, gets good gas mileage and whatnot, and then when you put it to the floor, everything changes. And it goes on to a fixed program, and all of these lies that you've told the computer put together enough fuel to make a boost. Because if you're going to double the amount of air that goes into the engine, or even in this case up it by 1/2, then you've got to up the fuel by 1/2, and it's all got to get together. But the fuel injection system was not made for a turbocharger. So here's how I did it. I'll go through it step by step, and at the end I'll put a summary of do's and don'ts from things that I learned and I guessed right, and things that I guessed wrong. Let me talk about the fuel injection on this Trike. It's a 1991 Saturn twin cam fuel injection. General Motors would call the car a VIN 7. tells what the information is that you can look for if you're using a scan tool. And the whole idea of fuel injection is that it needs something to be information to tell the whole system what's happening. You know, it wants to know when to fire the spark plugs. It wants to know when to open the injectors. And all of that comes off of the crankshaft. And the crankshaft is its information center to everything. Well, I don't have a Saturn engine, so if I don't have a Saturn engine, I have to make something that will inform the fuel injection computer what to do. And so here's how I did this. First of all, I took this this pulley that's on the end of the crankshaft, and I laid it out on a wheel. And on the wheel, I marked off what was going on. Now, there's a reason why this looks a little odd, and that's because they use number 4 as their reference instead of number 1, and there's a method in their madness. But here's how it goes. So, even though this is set off to the side a little bit, this is number 4, and it has 2 notches in it. And then if you move a little farther down the wheel, this one is 60 degrees, this is 120 degrees, this is 180 degrees, this is 240 degrees here on this notch, and this is 300 degrees, and we're back to 360 degrees. So the crankshaft makes one revolution that passes all of these, and the information off of the revolution of the crankshaft goes to the computer, like I said, and it will take care of fuel injection openings of the injectors, of the pulse that it sends. It will also say which cylinder is in what firing order, and if you don't have something like this, then it's the system won't run because it doesn't have any information. There's another thing that I should point out on this, and that is the crankshaft position sensor. So the crankshaft position sensor, I've got a white piece of paper back here, is right here, and that points very closely at the crankshaft. So if you've got a bad crankshaft, you're going to be in rough shape, because this thing is a mere 4/1000ths away from the crankshaft when the car is running. So if your main bearing gets too loose or something like that, it's possible that the car wouldn't start. In this case, the Trike wouldn't start. But this is the information microphone, you might say, to everything that happens as it passes by it. It changes the magnetic field inside the pickup sensor, and that goes to the computer or the powertrain control module, whichever you would like to call it. So when the crank angle sensor was in the Saturn, it had a hole in the block, and it went into the block, and when it went into the block, it came very, very close to the crankshaft, and that pulley that we just looked at a second ago substitutes that. And the crank angle sensor itself is pretty simple. It has 2 terminals here, and it has a magnet inside it. So as the pulley goes around and crosses this, magnet's pretty strong, and goes out the other side, it makes a magnetic wave that is sent to the fuel injection computer, and it knows that something has just happened. Now, what just happened, of course, is dependent on if it comes by the place where there's 2 slots or the place where there is 60-degree slots. So it recognizes as a circle as 360 degrees. It doesn't recognize the car as a 4-cylinder. That is programmed into the computer itself. So when it goes by and it has the 2 slots in it, it recognizes that that is number 4. So the spark jumps down the coil, or out of the coil, down through the engine block, jumps up the spark plug on the other side. Well, when there's 2 slots, it knows that that weak side over here is number 4. Therefore, its companion cylinder on the other side must be on top dead center and ready to fire. And so everything is calibrated, believe it or not, off of number 4. The engine doesn't have a camshaft sensor. So the wave of that dead waste spark on one side is the camshaft sensor as well as the crank angle sensor. Waste spark, it means that one cylinder and its companion cylinder both will spark, but one cylinder will be between intake and exhaust, and the other one will be at top dead center. So when I said on the little pulley that I showed in the last portion, number 4 is the one that they're worried about. And so when number 4 is on its waste spark, in the bottom of the module, it senses that that one had a very easy time doing it. And so if it had a very easy time doing it, that must mean that its companion cylinder is ready to fire, and it fires that one. If the crankshaft turns another 180 degrees, now it's the other way around. But when you first start the car up, it's looking for number 4. And these are really, really strong ignition systems. And I can show you that, but I'll turn out the lights. And when I turn out the lights, I'll unplug 2 of the spark plug towers, and you'll be able to see it jump across. It'll jump between these 2. And it is so strong that it can jump between those 2 towers, even though they're over an inch apart. As a result of that, I can run the spark plug gaps much, much wider. I can spread them out easily over 30 and just use the standard Volkswagen Beetle spark plugs. And they last years. They fire even if it's cold weather. The car starts, or the Trike in this case, starts up immediately and runs fine, even if it doesn't have all 4 cylinders working. If one spark plug goes down, it will still try to run on 3 plugs. It won't have any power, of course, because it has one dead cylinder, but that's the way that the ignition system works. It works sure shot. It starts in the coldest weather. It never hesitates, and out on the road, if everything is clean, you can drive in the rain, and it still works fine. Information about how dense the air is comes off of the air temp sensor. This air temp sensor would normally be stuck into the air cleaner. It's not in the case of this one. It's just on a hose that goes up to the air cleaner. And the idea of how dense the air is a big deal, because if it's really cold outside, the air is very dense, and it adds more fuel to it. If the air outside is really warm, that means that as you put it into the engine, there's less of it on each cycle, and so it leans out the mixture some. It's really simple. It just sits there, and as the air goes by it, as I'm going down the road, it takes the reading and puts it into the computer. Even though it's turbo, it really doesn't seem to make that much difference, because after it's intercooled, it pretty much is the same temperature as it is out here. This is the manifold absolute pressure sensor, and what it does is it kind of combines a whole mess of things that the car or the trike is running into, and it gives that information to the computer, the PCM. If you're above sea level, it knows it because there is less pressure. As you get down and down closer to sea level, the air gets denser and denser and denser, and there's more pressure to start with just in the ambient air outside the engine itself. Then additionally, what happens is that if you put your foot down on the throttle wide open, the pressure that is inside the intake manifold goes up and lets the air rush through the manifold and into the cylinder. It's flooded with air just being pushed down by the atmosphere, and when you let off on the gas, you block that supply of air, and that blocked supply of air in a way starves the cylinders, and you can go down to an idle. And so that's the job of the manifold pressure absolute sensor. The car will not run without it. Here's a throttle that I have locked in the vise in my rather dirty garage. And here's a throttle position sensor, and here's the throttle body that runs on a stock Volkswagen made in 1975 in Mexico. And it runs, the engine management system needs to know what position the driver has his foot in the gas. And it operates at 5 volts. It has one 5 volt, one ground, and then it has one reference voltage that it sends to the powertrain control module, or the computer as we could call it. And as the guy gives it the gas, the engine management gives it the gas. So when it's idling, it's around 0.7 of a volt to about 0.75 volts, meaning the PCM or the computer would interpret that as someone is sitting at a stop sign, for instance, or just hopped in his car at the garage and he doesn't have his foot on the gas at all. So it knows that it's idling. If it knows that it's idling, it knows how much air it's using, therefore it knows how much fuel to add to it. Then, as the guy gets out on the road and he floors it, the voltage goes way up. But on the way, it's going in increments. It goes a little bit more, a little bit more, a little bit more, a little bit more. And finally, when it's wide open, it's sending a signal that it's about 5 volts. Usually it's around 4.5 to 5 volts. And when that happens, the system stops looking at some of the emission control devices like the oxygen sensor and all of that stuff and starts pouring the fuel on wide open. Okay, so another thing that it needs to know is how quickly the guy did it. So if he did it slowly, that's one message. If he did it very quickly, it's another message. So it doesn't hesitate. Carburetors have an accelerator pump that gives it a little squirt, like a small squirt gun of gas. This isn't like that. This is all handled by the engine management. Okay, so how fast did the guy throttle up goes in there too. Does this have enough fuel delivery with this wide open throttle to handle the turbocharger? And the answer is no. You're going to have some other strategy to add how much the throttle position sensor pours on at wide open throttle to give it enough gas. If you have more power, that meant you have more oxygen, and you're going to have more gas to go with it. to keep the mixture balanced. So throttle position alone will give you a lot when it's wide open, but it doesn't give you everything. So this is the coolant temperature sensor off of a Saturn. It would screw into the water jacket. We have no water jacket, of course. So being we don't have a water jacket, we have to do something else. The fuel injected heads on the 1975 Volkswagens had a spot for a temperature sensor. So rather than put it into the water jacket, I put a piece of hose onto the head temp sensor hole and then filled it with grease as a conduit, and then put the the water temp sensor, into that and put a thing around it, and then I can read what the head temp is rather than water temp, and that is information is relayed to the fuel injection computer, and the fuel injection computer makes the mixture richer when it's cold and makes it lean or less of it after it warms up, because engines work on what they call residual heat. When they're cold, they don't have any heat in the engine, but when they're warm, they have some heat already, so they don't need that choke effect. And if they don't need the choke effect, then they can lean out the mixture. If you run your car around in the winter, you probably notice that it takes more gas. That's because it takes longer for that residual heat to build up. In the case of air-cooled engines, they used to have a lot of trouble with carburetors that the crankcase would fill up with gas because they never turned the choke off. They always seemed like it was getting, trying to get warm very slowly or never get warm and poured on the gas too much. These don't seem to do that, although with a Trike there's only so much weather that you can run around in and you call it off for the winter. Okay, this is a let's not have a heart attack part of the whole scheme here, because there are so many devices that the car was looking for, the car that you took the fuel injection off of, that it's going to throw codes if you put a scan tool on it like a love letter, because there are so many missing devices. Let's take, for example, this particular fuel injection system that I took off of this twin cam Saturn 1.9. It was a port fuel injection. So let's go up to the top on the left, and there's an idle air control stepper. They call that an IAC motor, and what it is it's a little bitty air adder, so if you turn something on rather than have the engine kill, it just adds a little throttle to it. It's kind of another throttle, and it would add if you turned on some of the devices, and it would subtract as soon as you turn it off, so the idle would always stay the same no matter what you did. That's gone. The next input is and output is the torque converter clutch and the drive second shift. It doesn't have an automatic transmission anymore, so that one doesn't apply. Then there's fan control. Fan control is if the engine gets up to a certain temperature, like about 230 degrees, the fan would kick on, cool it down, and then it would shut off. Or if you turned on the air conditioner, it would turn the fans on so that the air conditioner would be efficient, get rid of its heat from the inside of the car. That's gone. There is no air conditioner. And then the next one, of course, is the clutch for the air conditioner. That's gone too. The next one is the EGR, which is exhaust gas recirculation. That gets rid of a pollutant called NOx, and it's a little valve that lets some recirculated gas into the intake manifold to kind of cool down the combustion temperature. That doesn't exist. The canister purge, when the car's gas tank starts to get hot and the gas starts to evaporate, it evaporates it into a charcoal canister, and when the car starts up, it uses up that gas. There is no canister purge. So there is no canister purge valve. Then there's the malfunction indicator lamp. I don't have a malfunction indicator lamp. That's for a dash, and the dash went out with the car. And there's the data outline. It does have the data outline. It needs to get
It needs to show you the data. And if it needs to show you the data, that one will not be a code, but it will be something to plug your scan tool into. Vehicle speed sensor to the dash. It wants to show you how fast the car is going. Well, you don't need to know how fast the car is going because you don't have a speedometer that is driven electronically. You have one, in my case, that's driven by the front wheel. And so that's a dead end. That's another code. Coolant overheat lamp. When it got too hot and it was a car, the light would come on in the dash saying it's getting hot, so you better shut everything off. I don't know what's wrong, but it's getting too hot. It's out of coolant, or the water pump doesn't work, or something like that. Don't have that light. The rest of them in the top row are important. So if you get one that says fuel pump, or if the next one in line is ejector number 1, the next one in line is ejector number 4, the next one in line is ejector number 2, and the next one in line is injector number 3. So if you get any of those, you know you got a injector trouble. If you got a resistance in an injector that's bad, it's likely that it's going to show up on the scan tool. I never had an injector going bad, so I can't say that for sure. Then, of course, at the end, we have an ignition module, which is an ignition bypass. That's for the starter, and an ignition control. That's the little wheel with the 2 close notches, but that again comes down to the second row. The second row, let's talk about that. That's the one on the bottom, over at the left. The map sensor. The map sensor, the manifold pressure absolute sensor, the one that's 2 sensor in one. It's a barometric pressure sensor, so it knows how high you are above sea level, and it knows how much pressure there is inside the manifold. You would probably call it vacuum. And it needs that input. You've got to know it. You've got to know how much air the engine is using. The next one is throttle position. Likewise, it has to know how far you've got your foot in the gas. Both of those are still valid. The next one, hand wheel sensor, applies to the power steering of the car. When you turn the power steering on the car, it puts an extra load on the engine, so that stepper motor up on top will make the idle the same. That doesn't exist. Neither does the stepper motor. Next one, data link. Yep, your scan tool is going to use that. And once again, it mentions ignition module. So this time, it's mentioning the 2 little slots with the little 90-degree or the little 60-degree circle. And then also, it wants to know how many RPM it's spinning. So it comes out on the first part as to where the camshaft is, where number 4 is, and then the second part is how many times does it see it. So it went to pulse the injectors. Vehicle speed sensor, you can add that, but one thing that does is if a guy is standing still and some idiot puts his foot to the floor, you could blow the motor up. What it will do is it will limit the RPM. So if he can put his foot to the floor all he wants, but there's only so high the engine's going to rev up and it's going to cut him off. Next one is AC low and high pressure. That one doesn't exist either because there's no AC. Air intake temp, that one, if you get one, you better pay attention to that. Engine coolant, that one's valid, you better pay attention to that. And there's 2 more we haven't talked about yet. One is the NOx sensor, and one is the O2 sensor. The NOx sensor and the O2 sensor are really important, but we haven't got to that. We'll talk to those in relation to the turbocharger. So when you put the scan tool on, you better recognize that you're going to get a love letter of codes. So we finally got around to the turbo itself, and we've got through all of the other stuff that is trying to support this thing. And the turbo is an air research turbo off of a 1984 Pulsar NX. It's N10. And Garrett later bought Air Research out, And air research was really pretty much ahead of its times at that moment in production. And it runs 7.5 pounds standard boost. It takes it really easy, but on the other hand, on a vehicle that only weighs 1,000 pounds, 7.5 is more than enough. It was a water-cooled turbo because it was underneath the hood. It doesn't need to be water-cooled because it's not that hot, because there actually is no hood. I don't think that those things had an intercooler on them. This does have an intercooler. But anyway, this is the turbo system that I got, and the reason that I use this turbo is I got it free. The wastegate. This is the same wastegate that was on it when the turbo was manufactured back in the 80s. And it's a 7.5 pound, half an atmosphere wastegate. It has no adjustments to it. And I thought, well, 7.5 pounds is not really that critical. So I think I'll ride along with 7.5 pounds. Simple as can be. The hose comes out of the pressure side of the turbo, and when the pressure rises too high, the wastegate simply opens this up and bypasses the turbo, and it always stays at the same pressure. So with any turbo system, of course, one thing you have to do is a lot of plumbing. The plumbing gets cut short depending on what stuff you can buy. At the time, you could buy what they called a TP exhaust system, and you could buy it really cheap because there was Volkswagens all over the place, and everybody was trying to sell stuff for them, and they sold it cheap. So this TP exhaust system was modified where it hooks onto the turbocharger. A plate was made that adapted a 3-bolt down to or up to a 4-bolt system, and then safety wires. So a sandwich plate was made, and so the 3-bolt dump on the exhaust system dumps into the square part of the air research turbocharger. And granted, you could use bigger pipes, but if you're only dealing with 7.5 pounds of boost, you don't need very big pipes. This is a Blackstone intercooler off of a Saab. It is more than adequate to handle all the air that the engine will use. I'm almost sure, not knowing exactly the model of the Saab, that Saabs that older all were bigger than 1600 cc's. So I got the intercooler free, built much like a radiator is, aluminum core to it, plastic caps on the end. It's been on there for a very long time. So in the turbo plumbing in and out, the tubes were just bent out of exhaust pipes. It's as simple as that. I put on the intercooler off of the Saab, and then I sized down where it goes into the turbocharger, came out and made this big fat tube that went into here. Another big fat tube comes out of it and goes down into the plenum. It does not make the thing spool up very fast. So if you're going down the road, maybe 55, 60 miles an hour and you get on it, it really does pretty well with not too much lag. If you're at lower speeds, tons of lag. You'll never get it to speed up because you can drive down the road forever with no boost and actually see vacuum on the vacuum gauge up front, and it's just fine. And then when you get on it, if you're going fast enough, it takes right off and really pulls hard, which is kind of a safety thing. Let's say that you're going down the road and there's somebody coming off an on-ramp on Interstate 90 or something like that, and you, rather than back off, you want to outspeed the guy and you push on him, it pulls really well. It's not hard to pull 1,000 pounds. The trouble with the Trike is Trikes are shaped like a corn crib. They have no aerodynamic shape to them at all. So when you got going faster, It really, really does have a lot of wind resistance, so the turbo helps out a lot. So when it comes to oil pressure, everybody gets all wild about more and more and more oil pressure. The reality of it is that once the oil gets to the bearing, it goes on to what they call a wedge, where the oil begins to roll like a ball bearing. And once it gets to that stage of the game, it doesn't matter what the oil pressure is as long as there's enough of it. And the oiling system needs a source, and so the source of the oiling system on this is the galley that is the first feed for the rest of the engine, and where the oil sender is to tell you that it doesn't have any oil pressure. You know, if you're running around with the red light on, in the case of this one, it's the white light on, it taps in right here. So there's a long pipe, brass pipe, that goes into the engine, and then it taps for the turbocharger main bearing, and then on the end of it is the oil pressure sensor. So if I see the oil pressure light go on, I'll know one thing: the turbo has no oil feed. So if there's one thing you find out about turbochargers is they have main bearings in them just like a car. And if they've got main bearings in them just like a car, you got to have oil pressure, and you need enough. So this runs the same oil pressure as an engine does. It comes up here, goes around, makes a low loop, and then goes back into the main bearing, or goes into the main bearing of the turbocharger. And what the loop is for is that when you shut the car off, if everything siphons both ways, there will be oil laying in this low spot, so that when you start it up, the turbo is the first thing to get oil. If there's an air pocket somewhere down the line, the amount that's held in this part of the oil galley for the turbocharger lets it get a shot of oil right off the bat. Because if you take off the air cleaner, you'll find out that even when you start the car up, the turbo is turning at some rate all the time that the engine's running, whether it's got boost or not. And so this is the main oil line. So now we need to go to the oil drain. So right here out of the bottom of the turbo, this big fat tube comes down, and what this is it's a bent 3/4 inch piece of conduit. And the conduit is bent around, and it goes down, and this valve cover has a hole cut in it with a homemade, I should say, junction. And the homemade junction lets the oil back into the passenger side valve cover. Pretty simple. One thing that you'll find out about Volkswagen engines that are turbocharged, or any engine that's turbocharged, is that there is a lot of crankcase pressure once the boost goes on. So if you don't have a way to help yourself out with the boost, you're going to be really, really surprised to see oil trying to get out of every place on the engine it possibly can. So granted, you have to get rid of the oil that comes out of the turbocharger and get it back to the valve cover, but not only that, you're going to have to get rid of all of the crankcase pressure that results when all of a sudden this engine that's used to easy breathing is overwhelmed with the amount of gas that's being pushed past the rings. And I know that they have wider ring gaps on turbocharged engines as a suggestion, but this one doesn't have that. The boost really isn't on that long. And so if it really isn't on that long, then you can get by with a closer ring gap. So coming off of the valve cover down here is this hose. And that hose is something that relieves a lot of crankcase pressure. If you follow the hose up, along with the water or air temperature sensor being taped to it, it leads up to the back of the air cleaner. So when the crankcase pressure really goes high, it pulls in the air out of the crankcase or the breathe butt, so it adds additionally to the road draft tube that's on the other side. If you don't do that, you're gonna really have oil puffing out both ends of the turbo, and you don't want that. This isn't too bad either, because what's coming up doesn't pull the oil out of the crankcase. All it does is pull the air out of the crankcase, and if you look at the turbo is fine. One thing that I should also mention is if you're going to turbocharge, you better have yourself a good air cleaner. Turbochargers do not like dirty oil, and they do not like dirt in the air. So most of the things that you're pulling out of the crankcase is relatively safe air. It's not really that polluted, and it's coming out instead of in. So if you look in at the turbo when you start it up, it's spinning, and the compressor side is nice and clean, and the turbocharger has lasted decades now, so you can't be doing everything wrong. I know too that if you look on the internet, they'll say, well, you should warm up your turbo before you give it the blast. So rather than warm up the turbo before I get the blast, I just start it off and take off and drive down the road sanely for a little while. And after I drive down the road, let's say 2 or 3 miles, then I get on it. Most of the time when I pull out of here, I'm in a rural situation. I don't have to go fast at all. So I'll go down the road like 50 miles an hour. It doesn't suffer from overheated oil trying to carbon it up, because with the TP exhaust system, it is so high and so far away that actually people told me, does that thing get any boost with the exhaust that high? And the answer is, sure it will. Why wouldn't it? The air has got to go somewhere, or the exhaust gas has got to go somewhere. And turbochargers work on the still expanding gas that's coming out of the engine. It's one of the few things that actually recovers some of the lost energy in a piston engine. So here is some different pressure regulators. This is the actual regulator off of a old Volkswagen fuel injection system made in the 60s. So you would put the pressure gauge on it, and there was only one pressure that you dished out. Whatever you started up with, if you gave it the gas or if you let off of the gas, it always kept the same pressure. If you didn't have enough, you just loosened up the lock nut, and you turn this in or the out, and you watch the pressure gauge go up or watch the pressure gauge go down, and what you saw is what you got no matter what happened. This is a little bit further ahead. Now both of these look exactly the same, but they are a different pressure. This one had a little garbage screen in it to try to take all the junk out of the fuel injection system, and the other one doesn't have that, but they're different pressures. I picked one that had a much higher pressure. Well, if the fuel pressure regulator is sending fuel back to the gas tank, it's not sending it back to the gas tank all at the same rate exactly. If you're going wide open, it's using fuel, so the amount that it sends back, you might say, is a little bit of leftover that isn't quite as leftover as it would be when you're idling. Okay, so then you go to idle, and when you're idling, you don't need as much fuel pressure. You only need the fuel pressure to really go up when it's running wide open. So usually the fuel pressure on one of these is like 31 to 38. This is a different fuel pressure regulator, and it has to be different because if you're going to put boost on it, you're going to need more fuel. If you're going to need more fuel, you have to run higher pressures. Now, I know that if you went on the internet, they would say, oh, if you run your fuel pump too hard, then your fuel pump's going to die. Well, this fuel pump has been running hard for decades, and it never died. And it's been running with this fuel pressure regulator, which is not 31 to 35, but is substantially higher. So I'll show you by starting it up. I'll mimic having the throttle wide open by pulling the vacuum line off that controls the little diaphragm inside it, and you can see what happens when the fuel pressure goes up. Liquid fuel. It's a big deal in turbocharging because you need a lot of it compared to what you do with a naturally aspirated engine. By aspirated, I simply mean that one that's just running under normal atmospheric pressure. With turbocharging, of course, you have an enhanced amount of pressure, so it makes a little engine act like a big engine. And in this case, it starts off with this regular Kohler gas tank off of a, I think it was off of a digger, and it's 5 gallons. It has no vents in it, so as far as meeting any kind of an EPA type restriction, it didn't exist then, at least as far as gas tank emissions went. And so really it's legal for when it was made, but it doesn't do much for the atmosphere. Any gas that evaporates, of course, goes right into the atmosphere as hydrocarbon. So it's 5 gallons. It has a fuel pressure gauge, or it has a fuel sender gauge on it so that I can see the amount of fuel I got left as I'm going down the road. I usually go about 100 miles and stop, and 100 miles and stop, and stretch because I'm old. And when you're old, you can't sit down that long. So if I take off driving, I drive from here to Sturgis, South Dakota in 1 day. So I go about 4 stops. So the fuel comes out of the bottom of the tank, goes through the fuel pump around the system, and it returns. Anything that the fuel system didn't use comes back to the tank. So if the boost is on, or if you're cruising down the road and it uses so much fuel and there's some left over, it comes back to the tank. That was a very early way of doing things. Return lines were on practically all of the fuel injection systems back in the 90s, and this of course was included because this is a 1991. The fuel pump is off of a 280Z Datsun, and on the top of it, it has an accumulator on it, and the accumulator takes the pulse out. The pulse in a fuel injection system is bad because it's a pressure drop. So what you want to do is you want to have something that will accumulate the pressure, and when the injector is open, it doesn't vary very much. It keeps the pressure up. Otherwise, your mixture can wander, and you don't want it to wander. The injection system, even though it's multi-port, is not sequential, so that when all of the injectors open up at once, it wants to go down, and you don't want it to go down. You want it to remain stable. So that's what the little accumulator on top of the pump does. And the pump is designed for 280Z, which is 2.8 liters. The engine is 1.6 liters, and the reason that I used a fuel pump like this was, for one thing, it was free, and the other thing is that I needed a pump that could pump more fuel than the engine needed naturally. So if I have more pressure, more air, I'm going to need more fuel, and I have to have something that will keep up with the game. So if the engine is 1.6 liters and it was used to feeding an engine that was 2.8 liters, that should be enough fuel. So delivery potential is easily there. And so if I have 7.5 pounds of boost, the engine has to act like it's a half size bigger. And so if it's a half size bigger, if you have air that is pumping at a rate that makes the engine think it's half bigger than it is, you're going to have to add that amount of fuel. Otherwise, if you don't, you're going to detonate. And if you detonate, it's going to be the end of the engine in a pretty short time. So I need to deliver half again as much volume as your everyday 1600 cc Mexican-made Volkswagen would deliver. And so the theory is that a 1600 cc under boost is going to act like it's 2400 cc's. Here is the salvation of an engine that has turbocharger on it. This is a knock sensor. All it is a glorified microphone, and it only hears one tone. And the tone that it hears is the ping or the knock or the detonation, whatever you want to call it, that's inside the engine when something is wrong. And when something's wrong and it hears that noise, it turns back the ignition timing until it stops. And then it creeps forward till it just barely hears it, and it keeps constantly testing the water. Without a knock sensor, you're kind of flying by the seat of your pants. The fuel injection system has built-in properties that will help a guy like me that's trying to put 1900 fuel injection on a 1600 engine. And here is the oxygen sensor right there. So the oxygen sensor takes the readings coming out of the exhaust, sees how much oxygen is it, and corrects the mixture. So even though I have 1600 cc engine and 1900 cc fuel injection, it cranks it back so that when I'm on the open road doing nothing but cruising, it corrects the mixture and it makes the mixture ready for 1600 cc's. In other words, with everything I've done, it fixes it temporarily. The only time the oxygen sensor won't do its job is when I put the gas all the way to the floor. The oxygen sensor stops the reading and stops the influence. So let's just go over some of the things that are the high points, things that you need to make sure that you get right the first time. If you get something right the first time, all you have to do is spend the rest of your time tweaking the setup that you have. So I'll go down this list, and when you get your first try with your turbo installation, see if these things are all true and why they're true. Ball bearing turbos. You could go to a salvage yard and it is possible that you would get a hold of a ball bearing turbo, which has bearings in it like anti-roller bearing. And the deal with ball bearing turbos is it's not that it's bad at all. It's that you have to limit the amount of oil that goes to the turbo. Everybody says, well, you know, the more oil pressure the better. That's not the truth with ball bearings. Ball bearings need just a certain amount of oil and they don't need any more. So a lot of times there'll be an orifice in the line going to a ball bearing turbo. The likelihood is that you won't get a ball bearing turbo. And when you get your turbo home or while you're at the salvage yard,
look it up and see if it's a ball bearing turbo or if it's a standard shaft turbo. Probably it's going to be a standard shaft. The next one is clean oil. Clean oil from the first time you start it up till the time that your trike is junk. You've got to make sure that the oil is clean. Just like the engine. If you run the engine low on oil, you never get that metal back. If you run the turbo low on oil, even for a little while, you'll destroy it, because that thing is spinning over 100,000 RPM, and 100,000 RPM will be a lot of friction if there's no bearing left because you didn't do the oil. The other thing is you want warm oil. You don't want cold oil. Cold oil to the turbo is like sludge. So if you want to go out and cruise around for about a mile or two at real low engine RPM, that's fine. But don't start it up, take it out on the freeway and give it the blast. It needs to thin the oil out. It needs oil that's the right viscosity. So if you say 30 weight oil, that means that the oil is hot 30 weight. If it says 5W30, it means that it's 5 weight when it's cold and 30 weight when it's hot. But 5 weight when it's cold, thick 5 weight is too thick. Warm the thing up. Get that oil warm. Intercooler. Okay. Here's a good analogy, or whatever you want to call it, of what an intercooler would do. Let's say that COVID was going on and you went into a stadium, and in the stadium everybody was 6 feet apart. Boy, there wouldn't be very many people in the stadium. But let's call those people oxygen. Then what happens is they go through the intercooler and it shrinks, and suddenly the stadium is shoulder to shoulder. That's what an intercooler does, because as soon as you compress the air with the turbo, you concentrate the heat. And when you concentrate the heat, when it comes out of the turbo, it's hotter than it went in. So you need to get rid of that heat. And to get rid of that heat, you run it through an intercooler. Intercoolers are simple. You put them on, they just sit there, and the air passes through them. They're a heat exchanger that's as simple as a radiator with no water in it. But if you get a chance to get an intercooler, do it. You can run without an intercooler, but it does contribute to other problems. Scan tool. Get a scan tool and see a snapshot of the engine wide open. So for instance, if I would take this out, take my stand tool out, run it down the road just as fast as I can and nail it, and get the perimeter as wide open as I can, full boost, full bore, pull it just as hard as I can. Take a snapshot of it, go home and look at that snapshot and see how close you are to what you need to be. Should be 0.8 or 0.9 for an oxygen sensor reading, although the computer isn't really paying attention to some of that stuff. Your throttle position should say wide open. Your RPM should be way up. And if it has electronic spark control, it'll show you if the electronic spark control is in action. And if it is in action, a lot of times it will show you if it saw any detonations. So a scan tool is kind of a proof of purchase thing. You put all that work into it, you take the scan tool out, you run it hard, you look at what doesn't comply, what isn't playing nice in the sandbox, and you fix it before you go back out. If you're going to buy a turbo from a salvage yard, or buy a turbo retail, or buy a turbo user, any turbo that you buy, make sure that you have it sized right. So you go to a salvage yard, and the first thing you look for in a turbo is a car that's smashed up. That meant that it went to the grave with a good turbo on it. The next thing that you worry about is the engine inside of that car, about the same size as the engine in that trike that you're building. Don't have a 1600 like I got, and go into a salvage yard and get a turbo off of a 400 cubic inch engine. You'll never get any boost out of it. You say, well, I want a bigger and bigger turbo. No, you don't. You want the right size. You don't want one that's too small, so you overspin it. You don't want one that's too big. The reason I picked this turbo is it came off of a car that was 15 or 1600 cc's. If it's 1500 or 1600 cc's, that's what I have. And so I knew that it would probably work very well. A high mount, up as far as you can get it. This is on a TP exhaust system, which there is almost no of anymore. I think that they quit production. But the advantage that this had is that it was well above the crankcase. So when the oil gets into it and it goes down, it's got plenty of room. You never have to worry if you go uphill, downhill, side hills, other than rolling the trike, that any oil will come backwards up the tube or there will be any blockage. When the turbo's working, it's got to get rid of its oil just as fast as it got it. So it might be coming in under pressure, there's no pressure going out, so it has to just literally fall out the bottom into the return tube. Another thing is never, never, never run around outside with the air cleaner off. You'll be tempted to in haste. Take a second and put that air cleaner on. That turbocharger is spinning every minute that that engine is running. If I took this air cleaner off and looked in there and started it up, the turbo would be spinning. Wouldn't be spinning very fast, but it is spinning. And if you go down the road and so much as a pebble gets fed to something that's turning 150,000 RPM, there's going to be damage. Even if there's something that's smaller than a pebble, like dirt and grime, they can wear off the impellers on the turbo and the turbo becomes less effective as a compressor. And you want the turbo to be a good compressor, otherwise you might as well not have put it on. So never, never, never run with the air cleaner off. You can do it in your garage just for a while, but other than that, always have the filter going. The last one is detonation. This is the death of the whole project. When I said take your scan tool out and make sure it's running right, one of the things that you can watch on your scan tool likely is detonation. So what are the reasons that something detonates? Well, for one thing, it will detonate less if you have an intercooler because it'll be using cooler air, and detonation is a thing under heat. So that's the reason that you would want an intercooler. Another thing is you may have to burn premium gas, which brings us to the third thing. What's the compression on the engine that you have? If you buy a Volkswagen, you're in turbo heaven because the compression is lower than 8. It's about 7.5, somewhere in there, and that is perfect turbo weather. Okay, 7.5. So you put the turbo on and you set the turbo for 7.5 pounds of boost. That's a half an atmosphere. Down at sea level, it's 14, 15 pounds. When the turbo pushes on your engine at half, it's going to be about 7.5 pounds, meaning that it would be the equivalent of adding half of the compression again to the engine. So if you've got 7.5 to 1 compression, let's say that you got almost 8. That's 4. If you got 8 to 1 compression and the boost goes on, now it's 8 plus 4. So now you're way up in compression. So if you got 8 to 1 compression and you had 4 to 1, 4 more of them, wow, that's really getting up there. And it'll start to detonate. I wouldn't suggest on your first try that you even try going anything over 10 pounds. And in all likelihood, you'd probably be better off to stay at 7.5 pounds, because if you stay at 7.5 pounds, it'll be satisfying. You'll get up and you go to pass a car and you push it down and it will pull really hard. So then we come to another one. premium gas. I think I mentioned that. Premium gas is less likely to detonate. It has something that slows down the burn. Granted, it's burning really fast, but in combustion speed, it slows the burn down. When it's detonating, when you're driving down the road and it sounds like somebody's got a tin can behind you with change in it and jingling it, you're in trouble. So you have to make sure that the octane of your gas is high enough to kill the detonation. If it isn't, make sure you never put the boost on. If you have to fill up with regular, don't give it the hard boost. Keep it really mild. And then when you run that gas out, then get some good gas in, and then you can step on it. If you start to detonate, boy, you're heading down the hill really, really fast. One of the things that makes it detonate is timing. The computer I got on this, as old as it is, can turn the timing back, so it has electronic spark control as one of its lines of data. And when it's pushing, when I take that reading, when I got it wide open, I look to see if the electronic spark control is active. It has to be active. And then I turn around and I look at the bottom of it and see, is it detonating? If it's matched together, if you're rich, if you've got it, you have it all. You have it all. And you can run a stock 1600 motor, 7.5 pounds boost, with an old fuel injection system, time it anywhere you want, but get rid of the detonation. You can drive around all day and it will be just pleasing to drive. And if you want to brag about how much boost you've got, lie about it. But I mean, for yourself, keep it simple. And as far as chrome goes, don't worry about chrome. Get the thing running right, then paint and chrome and do all the stuff that you want, tuck the wiring nice. But first of all, get the thing running right and dependable so that you can drive long ways. You can hop on it, drive 500 miles in a day and never burn down. So the next movie that I make will be on the trike body itself. And believe it or not, the trike body itself was welded together with coat hangers and gas welding. So I'll see you then.